So good afternoon, everyone, and welcome back again for this Saturday's talk session of today's. We are very pleased to have our own Mr. P.D Mani Ji, sir, who is the technical director with JanyuTech. Mani sir has done his BE honors in mechanical engineering from P.D Tech Coimbatore, and after that from IIT Madras, he completed his M.Tech in machine design and automation. Initially, for a period of 1 year, he worked with Kirloskar in CNC machine design, then Simplex for 5 years, and then he migrated to Singapore. In Singapore, initially worked with one Japanese MNC, that is ERMS, for 10 years times, mainly into robotic automation area. And 2002, he started, got into his own business. He founded his own company, Automation and Controls Technology PT Limited. He's been actively into business since 2002. And from 2006-7 to 2018, he has done various projects, automation projects in India. That's over a span of 11 years. And from last 2019, he's from almost 2.5 years, he's full-time with JanyuTech, merged his business with JanyuTech, and he's working or taking responsibility of a technical director at JanyuTech. And during his association of working on different projects in India for 11 years, the kind of experience he gained while implementing these robotic automation projects in India, that he wanted to share today with us, the adoption of automation through robotic automation in India. And we are definitely sure that through his varied experience of almost 3 decades in robotic automation, he will be able to give us insights of all this industry in detail. Mani sir, it's over to you now.
Thanks, Rajesh, for your very detailed introduction. Good evening, everyone. Thanks for joining here. Actually, it's going to be, as Rajesh ji told, it will be more of a sharing experiences than a real formal talk. Just to again recap my number of years in with Indian customers and projects, though I lived in Singapore for the last 30 years. I would like to go a listing of my experience here in India. So after my IIT Chennai master degree, where I took machine design as specialization and that too automation as further specialization, more core focus on automation. So probably that was the key interest. I'm in robotics and automation for the last 30 years, teaching by Professor Radhakrishnan in IIT Madras. So mesmerizing that we didn't want to miss even a single class, especially in automation area. So after that, I worked for a Kirloskar for 1 year in CNC machine division. Then I moved to Reflex Automation and Robotics company in Chennai for 5 years. Then I moved to Singapore, and there I had a 10 years working experience with a Japanese MNC. Then I started my own in 2002. But from 2006 and 7 onward, we have done more business in India with ACTC. So that gives really a good interior look into discuss about this subject today. And 2019, I am here with JanyuTech doing the same robotics and automation business area. So in all these above experiences, we put net together, put everything together around 18 years in with Indian projects, Indian clients. So that's probably more relevant for today's topic. So going back to the first 5 years in Chennai, Sumit was it's a mixie manufacturing company, and the second son of Sumit Group, he was educated in USA, and he started a company called Simplex Automation and Robotics company. And we had a technical collaboration with American Simplex Corporate, which is again a subsidiary of Ford. So that time we had Simplex had a plan to manufacture robots here in 1987 when the company started. So when I was working in Kirloskar, once I find the opportunity in robotics, I immediately jumped to Simplex without knowing what we are really going to do in there. But the aim was to manufacture robots, and that time then government also was pushing robotics in defense sector. So most of the inquiries what we got all on defense area, mostly for welding application, and some are for some special application like plasma heating, those kind of special applications where you need a 6-axis robot movement, and it's all very intricate for the operator to handle. So with the collaboration with American Simplex, we all, Sumit was really minting money those years. Every day they were making around 2,000 mixing per day, which was a big number. So cash was no issue at all. So he sent all of us to USA for training for 3 months. Understand the product. We had a collaboration for 2 products. One is a 20 kg payload robot, another is a 10 kg payload robot. And mostly it resembles same for the reach and payload. So we had a real technical transfer. We got all the drawing from Simplex, and we started to manufacture here. Manufacturing here was really a dream of his group and his father and his group. But doing application, we had a lot of challenges. The only possibility is to supply to either defense or special customers where they have a special cost. That time with the import cost, everything, the robo cost around 25 lakh. Those days the operator was only 2,000. So except with the push from the government, it was difficult to go into robotics in defense. So we have done quite a good project with the HPF Avadi near Chennai for tank body welding. Only one portion of the tank body, not the whole. And Ordnance Factory Madak near Hyderabad for some special investment casting handling process, and DRDO Hyderabad again for investment casting and some plasma spraying applications. Then EID Parry ordered some the wash basin, the glazing, they call glazing. So those kind of special applications we have done. Even though the cost was high, they were not so much on payback period or anything, because being a defense and special process. So we had no issue in doing that. We have also done other automations during that. And after 5 years there, to be frank, we made the robot because all the components are made in India, the aluminum casting and everything, and motors all imported from USA. The challenge there was convincing the customer. The customers were very early to this market. So first of all, the first question is a basic question: why use only for motors? Then we say closed loop motor. Then they talk about DC motor, because technology also was evolving. That from stepper it came to DC motor, then DC motor with a separate encoder and with the integrated encoder, and then DC motor with the brush, without brush. So all these things are happening when we were manufacturing. So it was hard time for first of all to convince that this robot is a closed loop stepper, but it can give the required accuracy. And most of the people are talking with the theoretical knowledge, of course, because what they learn from colleges. They say stepper is not good for high speed, and we had to come across all those technical difficulties. But in fact, the practical requirement is whether the robot can lift that load and whether it can move at the speed, whether it can reach a point at a particular speed. That is what matters. And of course, it should be long lasting. And American Simplex used that robot for so many years, and they are employed around hundreds of patients inside Port. So that's one of the technical challenges we had, that mindset with the people that time to accept a stepper controlled robot, to a big size particular robot. And I moved to ERMS, I'm a Japanese MNC, and there I moved as just a sectional head. So there was no issue, it was just working. Somebody was taking project and we had to only execute the project, getting the product. Again, coming back to the like we didn't have enough components available in India. Everything had to be involved. Linear motion side was new to us, ball screw was new to us, a gripper was new to us, everything was new. But we imported many things. It's a big process, but we have done. So those days importing a component is it's like another project. So we have done that. And in Singapore, we didn't have any issue on those kind of area where getting parts. It's more or less electronic assemblies and handling is a main application area. It's not a heavy industry. It's mostly light and clean industry. So all are like a small robot, 2 kg robot, 5 kg robot. So that we didn't have. I didn't have, except for some technical challenges. Other area I didn't know. Yes, I only went for a pre-sale and then executing the project. Then that company had some financial issues, and they sold the company to an Indonesian group. In Indonesian group, I had more of this thing. I had to take up the complete responsibility for the robotics division. So apart from including sales, marketing, and even collecting the last payment was happened to be my commitment. The company. So after working there for 3 years, and that company also had some political issue with it was related to some Sugarto's Indonesian president Sugarto. So they had to close the Singapore operation. So the whole team we came out along with them. I had one partner with another 5 colleagues. So 6 people we came out of the company, automation control. 4 were employees, and I had one partner. So in ACT, the advantage was since ERMS was closed, so all the customers came to us, all the principals came to us, and we were the team running. We were the people contacting the principals 3-4 years continuously. So all know by name. So I had no issue in running ACT for 10 years in terms of business principles. Then we have done projects for Iran, Philippines, Indonesia, all the regions in Southeast Asia, and also some tie-up with European companies. And in India, especially in India, from 2006, we were active in India. We came to Mumbai MTech exhibition. We exhibited our stall with 2 robots, and it was a good start. There were hundreds of inquiries, but many are just enthusiastic inquiries. But we got a deal with LMW and the TVS in the exhibition hall. So then visited after the exhibition, we visited to these companies, and we got project immediately. In 2007, we executed 2 big projects, for one each for each company. So from there onwards, 5-6 years, we were very active with many of the Indian customers. So maybe I will show you some pictures which we have done in India that may be relevant to talk here. This is injector line which we have done for our TVS group. We did one of this line in 2007 and one in 2011. So this is a completely automated line. The machines are automatic, but the handling was manual, and it has all kinds of complications because the injector what they made is for Nissan, and the accuracy what they expected was very high. So they purchased all high-tech components inside this. This is also part of the line. That's assembly line. This is a testing line where we had 2 robots doing handling of the components for this nozzle injector. This is actually a heavy vehicles injector, CR common rail injector.
Yeah.
So this is testing line, which was the same injector, and this another testing line for laser marking. So then we have done another big project with the LMW for tactile spindle assembly, which is also fully automatic with around 4 robots in the inductable concept. All the materials is fed by manually every 1 hour using the pallets. You can see my cursor, right? The pallets and conveyors, and the machine produce automatically for 1 hour. It's not a very complicated assembly, but it has some precision components. Like around 7-8 components must be put together with this robot. And then they gave another big line, which is a tactile ring rail assembly line, which used 4 big robots for handling the component. And this line, they were actually so far TVS and all those things, they would have contacted the ROE and everything internally, but we never had any discussion on it. They have identified the project, collected a few offers from different vendors, and they awarded. Only for this line, what you see on the scene, LMW had around 10 people working in a ship to make this ring rail. And in 2007, I think the industry was going very crazy that the production they want to ramp up 2 times, 3 times. Just projected this thing, especially in automobile sector. Textile is actually it goes up and down. So they also projected high, and they purchased this whole line. In fact, they purchased 4 assembly lines, most of them using robotic component. And we got 2 lines, and then the line what you see behind is made by German company. So they awarded 2 lines to a German company. And this line was using 10 people in the ship, and so they were running 2 shift operation. But with the projection, they had to run 3 shifts. So it has eliminated almost like 30 people requirement, and they need only 1 person to feed the component in this line for every 1 hour, and then collect the material. Maybe you can see this. Just so this sub-assembly is made in this index table, and that's again using some small Cartesian robot and other robots. And this big robot is picking the sub-assembly and then putting on the main line, which you can see here. This is the long component is a customer's component. We are assembling around 24 assemblies on the top, and after it is assembled, then come to the next stage for adding some more components. So this line was completely built on scratch. They only showed us this operation, and we had to come out with the idea, we had to come with the solution, and we had proposed the components. And in Singapore, we had, this machine is built in Singapore, but meant for Indian customer. We were a distributor for Kawasaki robots and a distributor for the food driving. So we didn't have any issue in executing the family. There are a lot of challenges come during the execution. Material availability, material procurement was very easy there. I had mentioned one point here, probably I'll mention later also. The fabrication vendors are not ready to do one-off components here. Mostly they all look for multis or mass production component. Whereas we had some special companies in Singapore who can do even 1-2 pieces. They had 2 sections. One is a manual machine section, another is a CNC section. So they will play with that and then make sure they give a good quality. So this line was installed in 2010. First machine, and they're still using it with good production rate. So part of the same line. And we have also done one line for Calcutta. It's a solar wafer handling line. So it was using around 3 robots, 2 for handling the wafer and 1 for handling the solar casting. So these are the experiences which I would like to. So from this, I will take some examples to talk about the challenges what we face here. Then in Janyu, we have done a robotic project for the customer who makes glass fiber bobbin, which is using 3 robots. It's one of the big projects we have done last year. This is again one-minute video. So this is actually a packing line where bobbins are wrapped and then palletized. So we use 3 robots to tap the bobbin from the manually brought in trolley. The trolley had a lot of variations because of its use for manual handling. So we had to use vision-guided robot, which fix bobbin and then load on the run machine. And then the wrapped bobbin goes to the cutting station. We had two of such robots, one on the left and on the right. The palletizing robot is a single robot which can cater both the lines. So it picks up the bobbin, put on the pack. So this is quite a challenging project in terms because it's around the payload has to be a 50 kg. So currently, what you see is around 30 kg. It looks small, but it's a 30 kg bobbin, and we designed this line for 50 kg. And every 8 seconds, we have to produce one bobbin. We have packed one bobbin. So there are 7-8 sizes where the height, everything. So it's also quite challenging in terms of even though the same system can take care, but a lot of things are done on the software. And currently, we are doing one project which is for a big group for making cement cubes. They produce cement, and to test the cement, they make this cube and put under load test and see what is the strength experiences. I would like to share some of the points which are seen very very tough in terms of executing a project. It's mostly the difficulties we come across is actually a sales challenge. Concluding a project with the customer is a big challenge because most of the robotic applications are special. Mostly it is all customized, and either companies invest for increasing productivity or reducing cost of production and better or consistent quality. And sometimes some company, like if you any company related to a supplier for a MNC, then by compulsion of the client. For example, HP will say the plotter, the ink the cartridge has to be done on automated line only, no operator involved. So a vendor, a third-party contractor for HP will always look for automation line. And some companies do this for a corporate image. That means they may have 5-6 lines, and 1 or 2 lines they automate completely to give a better image to the customer, so that they are a few steps ahead of their competition. So for their continued business, they will. So these are some of the basic reasons they go for it. But when it comes to robotics, that is for any automation. So when it comes to robotic application, there are some processes which are difficult to do by man, or it cannot be done by man. So those are very easy to convince the customer. So for example, welding, we want a uniform quality, leak-proof quality, or without any defect, without any welding defect. So those, it's really, I mean, probably welding was the first application found as a robotic application. So most of the people go for that. They just go for the complete welding set, whether it is ROE with the customer, the welder or not, they don't mind because the quality is important. Similarly, the dispensing, like the glue dispensing in automobile area, where the windshields are dispensed with the rubber beading, those where uniform dispensing is expected, and also painting in automobile sector, where uniform thickness is expected, uniform finish is expected, plasma spraying. So all those things, no questions asked. They will just go for robotic installations. I think especially in robotic building area, we have hundreds of integrators in India who can do simple systems. And also in precision electronics assemblies, where you need to locate precision components on the PCBs. They use a linear robot, linear gantry kind of system. There also, it's very difficult for an operator to place a component within micron accuracies. For example, bags or boxes which are 25 kgs, 50 kgs. So those areas handling the whole day, I mean, it's naturally people, the company's management look for automation, and they just take probably 3 quotations and decide whichever is optimum for them. There is no calculation of big ROI there, return of investment, because they know all the 3 quotations are expensive. But only when it comes to easy to do application, or it can be done by man, it's only nice to have robots or nice to have automation. Here we have a big challenge in proving that this is cost effective, either by production rate or by speed or quality. Somewhere we have to convince the customer, which is really challenging. They say it's already very good. They will never accept that it is not good. So they calculate the number of ROE based on very short number of. For example, a biscuit company was running the same biscuit for the last 10 years, 20 years, and it will continue to do the same for the next 20 years. But when you want to put a robotic system, they take ROE for 2 years, which is definitely not possible. You need to have a big hardware to achieve that speed. So that's one of the difficulty in convincing in sales area, where how to implement, how to adapt a robotic system financially acceptable to the customer. And sometimes we had a problem, especially I can give one example in TVS. We quoted a system for 3 crores, and 2 crore was our, 1.8 or 2 crore was our material cost. Another company from Bangalore, which was an established company, but they had no business during that time. Probably it was down, and they are also well known to TVS Group. And they quoted almost less than the material cost of our system. We know because this company, TVS, has specified all the materials to be used in the system. They made all the robot should be this particular brand, this model, this version also. Then this laser marking should be this brand, this sensor to be this brand, this measurement system should be this. Everything is specified. So what different vendor can do, only making a structure in a different form or different cost. But that Bangalore company quoted less than the material cost, and they took the project. And I heard after that they had taken a lot of time in supplying the system. So those time we decided it was challenged to whether to give discount and take this project or not to take the project. So we decided not to take is better option. We didn't take that project. So another application before concluding the project is a financial challenge to convince on payment terms with the client, because for them also it is a new system, and it's doubt. We may have a supplier, we may have a confidence. Suppliers will have a confidence that we will definitely supply, because that's what we are looking for from the company. But customers will have a doubt whether these people can supply or not, whether they will complete it or not. So they are not willing to pay terms according to what is really required. For example, if you take a project, around 66% will be material cost. 2/3 or more will be the material cost, and further will be the overheads and margins. And this project takes some particular time to build the machines. So if you take up a project, say for example, many people are not willing to give advance, and some may be 20%, some may be 30%, some may be 25%. That means in 66%, if you take, we have to finance the project, we have to finance another 46%, and we have to finance the engineering cost until we go to next payment invoicing stage, which probably factory acceptances at the site, at our place. So that's probably 3 months, 4 months end of thing. So it becomes financially very tough for companies, at least MSCs, to finance, take up a project at a very competitive price, and also finance project which lead to a cash flow crunch. And the last stage, when we finally finish all the machine, the people again, companies have a lot of individual only. Company makes made by individuals only. So nobody takes a responsibility to sign, yes, I will take this machine to our place. So somebody has to sign the DO, delivery order, so that we can deliver the machine, and yes, if FAT is done and it's accepted, and we can pay the next 50%. So that takes a long time. Even though we did projects from Singapore with a lot of, we try to give a lot of reasons, but still the customer made sure that the line is power up, then they start paying the second phase. And the installation and commissioning, I no need to say, that will come only very late, with all kind of formalities, and the testing is done, which normally takes very long. So that's like this terms, getting a good terms from the customer is a big challenge for especially a customized robot. If it is a standard equipment, if the customer is not taking, we will sell to another person. We don't need even advance. We show the machine, we pay, or I take it back. So that we can't do when we are doing a robotic. Only the robot may be standard, but the whole system is built for a particular application, which can be never used in other applications, than using for the same application from another customer, which is rare generally. And another big hurdle, like terms, is schedule. Schedule normally it is squeezed. That goes everywhere, not only in India. But India it is more, because we take more time to decide. We take some years to decide on some particular project, and we negotiate for months together. But when it comes to execution, we want to do in weeks. We only ask how many days and how many weeks, which probably not true. But of course, when we want to take a project, we have to commit and take it, and we have to try very hard to achieve that. So that reduced schedule is one of the big tasks for any emerging companies, because we have no time in negotiating with our vendors. We need time to negotiate purchase material, which is purchase cost. When I was saying 66% is the material cost, or 70%, in that 50% will be 50 or 60% will be a purchase of material, which somebody is making. We have to buy and integrate. So that becomes a big task, and they don't deliver without 100% payment most of the time. So that becomes that time to source material, to source alternate material, becomes very difficult in a tight schedule. This is actually probably from the customer side, probably it's lack of knowledge on the intricacy involved in this project, or they will be knowing, but it's difficult to accept because of their own internal procedures, that they have to get the machine, or they have to do the system very fast. So after we conclude the project, for example, one is a cultural challenge. I would put it as a cultural challenge, as companies in different countries, different regions, and different parts have different understanding of the same project. different expectation, no? The machine look itself is expected differently with the different customers. That's why we always go with design approval. That means this is what I'm going to supply, and this is what we will supply at the end, so that you agree, then we will produce accordingly. But that comes to black and white, signing the papers and all those things. Again, there is always a hesitation. The main hesitation is taking up owning the responsibility, both on say customer side and even supply side. Also a project manager owning a responsibility is definitely lesser. And we also have in this cultural challenge is the fear of robotics. Now it is reduced a lot. Now there's no fear of robotics. Robotics now seen as just a machine with multiple axis movement. So we are ready to put even robots, and probably the cost also reduced. So even like in India, when we do projects in different regions, we have a different understanding and expectations. So we need to tackle all these things properly when we meet different customers in different regions. So that understanding of, yes, we have to do this, that mood has to be there for a successful project. Technical challenges we had a lot. Each and every project patient keeps it going, whether we have all these challenges or not. So that's okay. But I would like to maybe 2-3 examples where one of the line what we did for TVS, we had to dispense 22 milligram of Loctite on a product with plus minus 1 milligram accuracy. So it's a liquid, and it's almost like not even it's not water, not milk. It's slightly thick, not even oil, and it drips. The dripping accuracy is more than the whatever the tolerance we are talking. That we could control with some technique. But this 1 mg varies. Even somebody sneezes outside. When you're running the BIOF test, somebody is walking fast. This 1 mg is varies. So those kind of techniques that we have to do many things at in the machine to isolate things and correct that. Another example I can give is a solar cell handling. We had a good experience in electronic wafers. Whereas solar wafer is very brittle, which we didn't know in the starting. We only know it's a 0.2 mm thickness. And when the customer gave first time, they were not having the sample first. So that was really unexpected challenge we had to tackle. There were not enough solutions that time available I'm talking around 10 years back. And finally we could do with some adjustments and technical component. And in Hyderabad, we have done one project for DRDO where a gripper has to rotate at 200 RPM. Those days when we did a project from Chennai, gripper itself we have to import, and the rotating gripper was not, we couldn't get anything. So we designed that gripper, and we did almost 6 iterations to come to finally a perfection. Okay, then comes the total execution challenge, which is the project management. I will just show one slide which okay. So this project management, this understanding, I would say it's very we are not can hear me, right? So any project, any small project, big project has these phases: initiation, planning, execution, control, and closure. In this, I will just want to discuss only about the initiation, where we got a document called project charter. This is a project document which has to be clearly signed by a client and our people. So this is what we supply, this is what we supply in time, this is what is included, this is what the performance, all should be written very clearly. So in project management, this golden triangle is very, very important thing to understand. Scope, cost, and schedule. All these three has to be, is all interlinked, which has to be maintained properly from the start to end to make a perfect quality product. So, but because of the understanding and not proper project document created in the starting, or changes during the project changes, so it slips, the project delay, or sometimes it go to failure. So scope is getting added, but the time is reduced, and sometimes we don't have for an increased scope, there is no budget added. So that makes it difficult for a manufacturer to, and sometimes unrealistic plan and schedule. Then initial, as I say, project charter, the document, we don't collect enough data to make a clear project document. So that becomes one of the, because we are not involving all the stakeholders. There'll be automatically some new stakeholder come along the way, and he will have his own requirement, which cannot be avoided. You have to do it. And another part is the lack of resources, because any robotic projects or automation project, the engineering manpower is very critical because we need to train them in a different area. It's not a normal control system, normal software. The understanding of the robotics matters. So that when the manpower keeps changing, or when we take new people, training of them all takes time. So this is another big challenge for a supplier to provide a good solution on time. I would like to point here. So with that, I think these are the main challenges so far I have experienced. Okay, but still the passion is on, so the automation road will continue to go very fast. And especially in Janyu, currently we are taking up very challenging projects which are not commonly done by a normal manufacturer. With that, I think I should conclude here. I open for any questions.
What is the present situation compared to on the vendor system and the technical availability of technical resources?
Yes.
Past and the present, do you feel there is a progress there?
There's a lot of progress. Now we see we have no issue on knowledge on the products and also availability of products here. So all the products, whatever we have, we are talking anywhere in the country. Either you talk Singapore or Germany or US, everything is available here. It's dealt by somebody here.
Since you have been living abroad for quite some time, how do you see the adoption of 4.0, Industry 4.0, Indian adoption, and advanced countries have already adapted to certain level? How do you see the progress in India soon?
Actually, when I was in, say, 2016-17, we were talking this IoT of common, especially automation line. I'm not sure about other software-related products.
Okay.
In automation area for the factories, still we are talking only. There is no, even other countries also. I will take Singapore. We used components which are, basically people are talking, but the components are very expensive. You buy a normal sensor, it will cost, for example, if I tell rupees, it costs 3,000 rupees. If you buy a sensor with the IoT option, it costs 15,000 rupees. And we don't need to really know that the sensor is going to fail after so many cycles. I mean, we are not in that kind of hurry or in the manufacturing lines. We don't need to it can be even a breakdown maintenance, not a problem. Instead of paying that price, customer will think that it can be a breakdown maintenance. So IoT is still, I would say it is still in talking stage.
Sir, I had a question.
Yes.
Relating to the NSC track failures, sir, my assumption was that if we do the simulations, then these problems could be avoided. So what's your thought about the design challenge and not using the simulation?
There are projects which come to us with a lot of, as we say in the robotics, it can be, components can be standard, but only the process may be different. Whereas in projects like a defense product, comes with a lot of challenges. It comes with other like a drop test, weight reduction, and severe atmospheric conditions, severe environmental conditions. So those kind of challenges will be there to use experts in those areas to understand if anything specifically we want to do. And in this place, I want to add one more thing which is related to the project management, which may be also related to this. There is a tendency called gold plating by the employees of both the customers organization and also the supplier organization. The main customer asks for something or which is not in the project requirement, but this employee is ready to just support the customer or to please the customer without knowing that it comes with a cost and time. That is what is called scope creep, which changes, which goes unnoticed by in many cases by the management or by project team. So it's between employees of this company and employees of the customer company, and they ask that this guy started doing it. It may divert the whole project in a different way sometimes.